The lakes of Saturn's moon. NASA's scientists have concluded that at least one of the large lakes observed on Saturn's moon Titan contains liquid hydrocarbons and have positively identified the presence of ethane. This makes Titan the only body in our solar system beyond Earth known to have liquid on its surface. Adam Hadhazy, writing for Scientific American, noted, "Just in time for a summer holiday, scientists have discovered the solar system's newest beach destination." While a sojourn to Saturn, or a journey to its neighbor Jupiter, may be decades or even a century away for spacefaring humans, robotic spacecraft have for the past several decades made the long trek to the outer reaches of our solar system, and some, like Pioneer and Voyager, have even left it. Titan's dark liquid lake, named Ontario Lacus after the North American Great Lake of similar size, has a light shoreline in what looks like a beach and may be noted in future textbooks as the first verified extraterrestrial body of liquid made up of hydrocarbons, simple compounds found commonly here on Earth. Before Cassini, scientists thought Titan would have global oceans of methane, ethane, and other light hydrocarbons, but more than 40 close flybys of Titan by Cassini showed no such global oceans, but instead hundreds of dark, lake-like features. Until now, it wasn't known whether these features were liquid or simply dark solid material. This is the first observation that really pins down that Titan has a surface lake filled with liquid, said Bob Brown of the University of Arizona's Lunar and Planetary Lab. Saturn's large moon Titan, the second largest in the solar system, has long fascinated astronomers with its hazy orange atmosphere. It is the only moon with such a thick gas atmosphere, extending over 600 miles from the moon's surface. Titan's unique atmosphere contains mostly nitrogen and traces of methane and other hydrocarbons, including propane. So not only will you be able to hang out at the beach, but you'll be able to have a barbecue. In your spacesuit, of course, due to a distinct lack of breathable oxygen and a very cold temperature. Titan is bigger than the tiny planet Mercury, with a diameter of 3,200 miles, and only about 25% smaller than Mars, and just a little smaller than Jupiter's moon Ganymede. This new finding supports the idea that Titan has a hydrological cycle, as does Earth, but instead of water-forming clouds, raining and evaporating, methane and ethane do the job. NASA and the European Space Agency have been discussing a return to Titan, and this news helps the case to send a lander or a floating probe into the lake on Titan to sample its contents. The question arises, could anything be living in that pool? When images of Jupiter's ice moon Europa showed what appeared to be cracks in its icy surface, possibly due to a warmer ocean under the surface, kept warm by tidally generated heat, an effect of its orbit around the gas giant Jupiter, artists' images appeared of life forms swimming in its depths. So far, there is no evidence that life exists on Europa, but the likely presence of liquid water has spurred calls to send a probe there as well. Life may exist in Europa's under-ice ocean, perhaps subsisting in an environment similar to Earth's deep ocean hydrothermal vents, or the Antarctic Lake Vostok. Life in such an ocean could possibly be similar to microbial life on Earth in the deep ocean. But what about Titan's deep hydrocarbon liquid pools? This dark lake absorbs nearly all light, which means it would look dark to the human eye, says LPL's Brown. The data also reveals that the lake's surface is smooth, without any ripples or waves, which Brown found surprising. They had expected to see some wave action caused by winds there. So, no surfing, folks. It's probably a long shot that there's life on Titan. Jonathan Lunine, a professor of planetary science and physics at LPL, said, "It depends on how open a mind you have. If you throw an Earth organism onto the surface of Titan, it will die, but there is a chance that liquid hydrocarbons could sustain exotic forms of life." The confirmed presence of organic compounds along with nitrogen means that Titan has a similar chemical makeup to that of the very early Earth, when life first developed. These compounds are the building blocks of complex molecules like DNA, and NASA scientists think that the chemistry necessary to create information-storing and self-replicating molecules like DNA may have stopped on Titan due to its very frigid temperatures, averaging about 300 degrees Fahrenheit, below zero. The lack of liquid water on the surface, the crucial ingredient for life as we know it, is another reason why life, if it ever began on Titan, may not exist today. But Dr. Brown pointed out that volcanoes and tectonic activity could add energy or even water into the mix, and he said if that happens, then all bets are off when it comes to life emerging in Titan's cold and harsh climate. Dr. Leibniz said, if we were to find life on Titan, it would show that life is truly a fundamental cosmic phenomenon, and that it can happen in conditions that are very different from what we would consider habitable. The existence of oceans or lakes of liquid methane on Saturn's moon was predicted more than 20 years ago, but with its dense, smoggy atmosphere preventing a closer look, it wasn't possible to confirm it. Scientists reported evidence of the presence of lakes filled with liquid methane in a 2006 Nature cover story, and now 2 years later NASA confirms Titan's ethane liquid lake. An artist's conception on the NASA Cassini Jet Propulsion Laboratory website shows a mirror-smooth lake on the surface of a smoggy orange-red moon. The liquid ethane was confirmed with Cassini's visible and infrared mapping spectrometer, which picked up the hydrocarbon's telltale light spectrum signature. The instrument identified chemically different materials based on the way they absorb and reflect infrared light. The ethane forms when the sunlight breaks down methane in Titan's upper atmosphere. They think that this ethane then forms clouds and rains onto the ground, creating streams and lakes. Ethane and other hydrocarbons are products from atmospheric chemistry caused by the breakdown of methane by sunlight. Some of the hydrocarbons react even further and form fine aerosol particles. All of these things in Titan's atmosphere make viewing the surface difficult because they cause a thick smog. So don't expect much of a tan at your Titan beach blanket barbecue. In July of 2006, NASA determined some other characteristics of the lakes, hypothesizing that the varying states of how full the lakes appear suggest that they might be temporary on some unknown timescale. As Titan's seasons progress over a 29-year cycle of Saturn's orbit around the Sun, lakes in the winter hemisphere might expand by a steady rain, while summer hemisphere lakes shrink or dry up. Some lakes have curvy channel-like extensions, similar in appearance to terrestrial flooded river valleys. Bright patches near some lake edges could be small islands peeking through the surface. Floating icebergs are unlikely because most materials would not float in liquid hydrocarbons. Cassini-Huygens is a joint NASA-European Space Agency and Italian Space Agency robotic spacecraft mission currently studying the planet Saturn and its moons. It was launched in 1997 and entered Saturn's orbit in 2004. It consists of two main elements, the orbiter, named after the Italian-French astronomer Giovanni Domenico Cassini, and the Huygens probe, named after the Dutch astronomer, mathematician, and physicist Christian Huygens. The Huygens probe separated from the orbiter and reached Saturn's moon Titan on January 14, 2005, where it made an atmospheric descent to the surface and relayed scientific information. In 2008, NASA announced a 2-year extension of the Cassini mission. It is the first spacecraft to orbit Saturn and the fourth that humans have sent to visit the planet. This is Rita Qawl, Director of Educational Programs at Challenger Center for Space Science Education, signing off.